So here we have a very standard question of momentum conservation. So the question is that a stationary bomb explodes into three pieces. One piece of some mass moves with some velocity at right angles with another piece of mass 1 kg and moving with some other given velocity. And we have been given the mass of the third piece. We need to find the velocity of the third piece. You can take some time to read this question and then let's go to the solution. Okay, so right here we have a bomb which exploded and the 2 kg mass went with a velocity of 8 meter per second. So let's say that it went in this direction, 2 kg and 8 meters per second. And the another mass 1 kg moves with 12 meter per second in a perpendicular direction at right angles. So let us say it goes here. This is 1 kg and it has a velocity of 12 meters per second. Now the net velocity, or you can say the net momentum of these two will be, since they are at right angles by the rules of vector addition, the net momentum of these two will be somewhere in this direction, right? Now since the bomb exploded only due to internal forces, there was no external force involved, right? So the overall momentum will be conserved, and since initial momentum was 0, so the final momentum will be 0 as well. So by common sense we can say that the last piece, the 0.5 kg piece, would have gone somewhere in this direction, and these two should balance out in such a way that their net momentum is 0. So let us find the momentum of these two. Momentum is mass times velocity. So 12 into 1, or you can say 1 into 12. So the momentum of this is 12 kg meter per second. Similarly, the momentum of this momentum is represented by the symbol P. That's 2 into 8. That's 8 meter per second. 16 kg meter per second. And hence the net momentum of these two will be the Pythagoras of these two, because they are at 90-degree angles. You know the formula for addition of two vectors is a square plus b square plus 2ab cos theta, right? And since theta is 90, so cos 90 is 0. So it is simply 12 squared plus 16 squared, which is 144 plus 256, and that's root 400, which will be equal to 20 kg meter per second. Now when the momentum in this direction is 20, so in this direction the momentum must also be 20, and if it is the case, we can say that 0.5 multiplied by its velocity will be 20, because this has to balance out the momentum of this, and hence we can say that the velocity will be 20 divided by 0.5, and that is 40 meter per second. So this was a typical question of momentum balance. Remember, if the net external force is 0, the momentum of the system is not going to change. Energy can change, but momentum cannot change. Okay.